value. Okay, so let me take that value here. Therefore, the area of the solid of revolution will be, therefore, area of the surface of revolution, in this case, surface of the revolution is given by A is equal to this formula, twice pi are taken out, this is 0 to 4a, x into dx upon dx is this value, this is under root. Okay, so this value is 4a plus 9x upon 2 under root a. That let me take here. This is twice under root a. But 4a square root is twice under root a. This is dx here. Now if I substitute this value something else, what is that value? Let me just find out that. Because square root is to be eliminated. Now let me put that square root something in a square. If I take it as, let 4a plus 9x is equal to t square. Let me take, we have substituted t square, then differentiation of this will give us, okay, differentiating with respect to x here, so this is 9 into dx equal to 2t into dt. That means this is dx, therefore is equal to 2t dt upon dx here, sorry, upon 9, I'm sorry, upon 9 here, the value of dx. Now limits, let me change with the limits here. Limits at, in this case, at x equal to 4a, if I put 4 9 is 36, 1 9 36, 36a plus 4a means 40a. So 40a, let me write here, at x equal to 4a, upper limit we have calculated. 4a is equal to t square, so t is equal to 2 under root 10 into a. Under root a is also there. 2 under root a, under root 10 or under root 10 a, no problem. Because this is 40 means 4 into 10. Okay, so 2 under root 10 into a, because square root a is also there. And lower limit at x equal to 0. And at x equal to 0, what is t here? T square equal to 4a only, this x is 0. 4a, that means 2 under root a. Therefore, t square equal to 4a, or t equal to 2 under root a. So limits are from this to that. Let me write here the limit. Therefore, area a is equal to this twice pi upon 2 under root a. Alright. Now limits are 2 under root a to 2 under root 10 a. Under root a is also there. Let me write 2 under root 10 under root a, no problem, multiply. That is there. Into x. Now x we have to find out. From here, it will be t square minus 4a upon 9. So it will be t square minus 4a upon 9. This is value of x here, because here it was x. So x is equal to t square minus 4a upon 9, this value, into, now from out of this, because this is t square we have substituted, so t will come out from this, t then into t. Second value of dt, sorry, dx is now 2t into dt, 2 into t into dt upon 9. Let me write here clearly. This is 2 into t into dt upon 9. So this is that value. Let me write here. For the this value to cancel out first, and this is pi upon under root a into under root a. Sorry, what I'm writing here. This is 9 9 is 81, and this 2 again has come out. This 1 2, and this t square. Okay, so that value will be inside, but 9 into 9 81. So this is 81 pi upon 81 under root a. Under root a is left over here. 9 9 is 81, and this 2 also has come out. 2 pi upon 81 under root a. Okay, limits to under root a to twice square root 10 the square root of 40 into under root a, or we could write under root 10a, no problem. Let me write here 2 under root 10a into this t square. Now left over 2 upon 9 are taken out, so this is t square now multiplied. This is nothing but t4, t square into t square is t4, 4a into t square into dt. Okay, now let me integrate them. It is twice pi upon 81 under root a. Integration of this will be t5 upon 5 minus this is 4a into t cube upon 3. Now limits are 2 under root a to 2 under root 10a. Now we will substitute in place of t. That will be the final answer, but let me now finally calculate that. So what is the final answer? So area of the surface of revolution about y-axis in this case is a is equal to twice pi upon 81 under root a is already there. Now it is 5. If I take 15 out, then it will be 3 into 5 times for 20 into this. That will be there. Can be done in that way. So 15 if I take out, it is 15 into this I have taken. Okay, so first I have to put the upper limit. This is 3 here. 3 into t5. Okay, first let me write t5 here. Still I am not writing the. This is 20 into a into t cube. Now limits 2 under root a to 2 under root 10a. That is the point. Okay. Now let me solve it. So I have taken 15 LCM here. 15 on the 15. Let me write here. This is twice pi. Or 15 on the 15 5. 15 8 jump 120. Yeah. 120 plus 1. 121. 121. 1200. Because 15 on the 15 5 1 carry. 15 8 the 120. 120 plus 1 120. So it's 1250 in this case. Under root a, this value. Now we have to solve it. This is 3 into t raised to power 5. That means it will be 32. 2 raised to power 5 is 32. Okay, 2 is clear. Now 10 raised to power 5 by 2 into 10 raised to power 5 by 2 into e raised to power 5 by 2. Sorry, e raised to power 5 by 2 also. Okay, minus sign 20 into a into t raised to power upper limit I am substituting at the moment. It is t raised to power, but a is already there. So a raised to power 1 plus 3 by 2 means 5 by 2 same value. A raised to power 5 by 2 again it has come. Okay, into 2 raised to power 3 is 8. This is into 8. Okay, into 10 raised to power 3 by 2. 10 raised to power 3 by 2. Now minus sign. Lower limit. This is minus sign. First is negative, second will be positive. It's 3 into 2 under root a whole power 5. Plus sign. Now 20 into a. 20 into a into t cube. That means 2 under root a whole power 3. This is the value. Okay, let me check what value comes out. It's 1215 under root a. Now in the numerator, what do we get? Now a raised power 5 by 2 if I take out, and here it is 5 a raised power, okay, this is also 5 by 2. This is also a raised power 5 by 2. No problem. So a raised power 5 by 2, a raised power 5 by 2 can be taken out. A raised power 5 by 2. A square will be left over because minus half in the denominator. If I subtract 4 by 2 will be left over then. But 5 by 2 minus 1.2, that means 4 by 2 is square. A square is there. Okay. Now only numerical value let me talk about. First is 32 into 3 sorry. This is 96. 3 2 just 6 and 96 into 10 raised power 5 by 2. 5 by 2 is 2 and half. So 10 square is 100. 10 100 into under root 10. That value will be there. Under root 10 is there. Okay. Then minus this value, minus 20 into 8. And this is 110 will come out. And this is 200 into 8. It was 1600. That is 1600 then. We have taken, and 10 is square root 10 is left over. Square root 10 here is left over. Then next value a we have taken out, no problem. So this is 3 to the 2 raised power 5 is 32 into 3 96 minus 96. Okay, 2 raised power 5 is 96 only numerical value. Minus 2 raised power 3 is 8, 8 to the 16, so 160 plus 160 only. This is plus 160. Okay, 2 raised power 3 means 8, and this a raised power 5 by 2 I have taken already out. This is 160 only because 8 to the 16, 160, 20 into 8. This is the value. Okay, now we have to subtract these two. It's equal to 10 values. It will give us twice pi a square now divided by 1215. Within bracket this is 9600 minus 1600. What is the difference? This is 9600. Okay, and 1600. It is nothing but 800 only. 8000 only. 0 0 is 0 and 8000. 9600 minus 1600 means 8000 under root 10. This is 8000 under root 10. Plus sign now. 160 minus 96. 160 minus 96. This is 4 here. This is 6 here. And only 64. Only 64 is there. This is 64 here. Now something can be taken common. 8 can be taken common because it is 16 can also be taken common. If I take 16 common, then 16 5 is 500. Again can be taken common. 64 can be taken common. That value is there. So it can now come out because this is 16 into 4. 16 is taken common. Then this is 8. If I take common, then it is 1000. 8000 it was 9600. It is 8000. So I can take some common value. So something is common here. So what is common out of 64 into this? So this is nothing but twice pi into a square, because odd number is there in the denominator, so cannot be cancelled out. Only the numerical value is some common. Let me take 16 common. Okay, so that will be 500. Again, that can be taken common. So this is 16 I have taken common. If I take 16 common and within bracket divide by this is 1215. I have taken 16 common here. So this is nothing but 500. 16 5 is 80, and this is 500 under root 10 minus 4 here. 16 4 is 64. Again 4 is common. Okay, 4 can be taken. So this is 125 under root 10. So this is 4. If I take common again, so this is 4 1 is 4, 1 carry, 4 2 is 8, 4 5 is 20. So 125, then it will be 4 4 is 64. 64 into 2 is 128. Because 64 I have taken total common. So 64 into 2 is 128 a square, sorry, pi a square divided by 1215, then bracket it is 125 under root 10 minus 1. This is the final value. Okay, this is the final answer. Area of the solid generated by revolving that area, that surface around y-axis. This is question number 3 here. This is the final answer. Question number 3. That is done. Okay. This is about the question. Answer is in this numerical value. Okay, so this is question number 3 we have done. Now let's talk about question number 4. What does question number 4 say? Let me check it. Now question number 4 is this. Find the curved surface area, curved surface of a hemisphere of radius A. Here hemisphere is given. What is the surface of a hemisphere? This is question number 4 here. So first of all, surface of a hemisphere of radius, it says A, of radius A. And the curved surface of a hemisphere of radius A. Now if I draw a hemisphere, let me draw a hemisphere like this. This is the hemisphere. And this hemisphere is generated by an arc. This is the arc here. Let me take, this is A, this is O point, this is B point, this is x-axis, and radius is A here. This is A. So this arc is revolved about axis of x in this case, or this radius of this semicircle. This arc is revolved about x-axis, or then this hemisphere will be obtained. So this area, this surface which is generated, this is revolved about this line, this x-axis here. This is y-axis. Now taken x dash O origin and this. So this is radius A. So limits are from 0 to A. So this arc is revolved about, if I take P and Q here again, this is the strip P, Q, and this is ds here. Length of the arc is this ds. This is not we are taking, this is m into n. Let me take. Okay, so this is the strip, elementary strip, and this ds is revolved about this line. This area is revolved about, and total area from 0 to A. This is A here. The solution, let me write. So area of the, here the hemisphere is generated, hemisphere is obtained by revolving the arc. This is this quadrantal arc or quadrant arc AB around or about the x-axis or the axis of x, or about this diameter of this or radius of this. Because this hemisphere, this arc is revolved about x-axis in this case, axis of x. So this is the area we have to find out. So this area is given by the same formula we write. Limits here 0 to A. This is 2 pi into pi into ds. Okay. So here, what is the area of this? It's again a semicircle here. So that is x square plus pi square. Radius is a square. With this arc of circle here, semicircle, or arc of a circle here. Okay, so this is x square y square d square. Therefore, differentiating with respect to x, we will get twice x plus 2y into d by dx equal to 0, or d by dx equal to minus x upon y value. Therefore, ds upon dx we know this is square root 1 plus d by dx whole square. This is the value of this differentiation or differential coefficient of s with respect to x. This is given by this. So now dy upon dx is this. If I obtain this, this is 1 plus nothing but x square upon y square. It will give us x equal to y square in the numerator. That means x square plus y square upon x y square. It is nothing but a square upon y square square root. That means a upon y we will get. The value of ds upon dx is a upon y. Why? Because x equal to y square equal to a square. If I substitute here x equal to y square equal to a square, that means a square upon y square, square root is cancelled out. A upon y. Okay. Let me write here. Oh, so this is 2 pi. I have to take area of the hemisphere in this case. This is 0 to a. Y is, okay, let me substitute y as it is. But ds upon dx is, this is ds upon dx. Okay, let me first write ds upon dx into dx. This is the basic formula, 2 pi. Now let me substitute the value of ds upon dx, which is nothing but a upon y. This is a upon y. Now y by cancel out. This is dx here. This is nothing but 2 pi into a constant I have taken out. 0 to a. This is dx now. Integration of dx is x. This is 2 pi into a into x. Limits are 0 to a. Again, a is substituted in place of x. We will get 2 pi into a square. This is surface area of a hemisphere. Answer is this. Same answer. Because we know that surface area of a sphere is 4 pi a square or 4 pi r square. We just calculated first question. Question number, sorry, which one? Find surface area of the second question. Here, there it was, the radius was r. In this case, radius is a. So here, that volume was surface area was 4 pi r square. In this case, the volume of, surface area of a hemisphere is half of that, is 2 pi a square. Same answer. So answer is 2 pi a square. Here radius is a. Their radius was r. This is the answer here. Okay, so question is okay. Now this is question number 4. We have done. Now let me talk about the next question. The next question is question number 5. Let me check it. What does it say? Question number 5. What does it say? Now, fifth question is, this is sixth one. Okay, now fifth is, show that the surface of the spherical zone contained between two parallel planes is 2 pi ah, where a is the radius of the sphere and h the distance between two planes. The distance between two planes. Okay, so let me first draw the figure. What does it say? Here a sphere we will take x square y square into a square, undoubtedly that is equation of the circle. Now it says that sphere is there. So if I draw a sphere, let me take this sphere like this. Now two planes are there. Now it says that this is one of the planes. Second plane is this. I draw a, these are two spheres, two planes here which are cut from this sphere. Now the distance of the first, let me take any, and the distance between these two planes is h. It says this is h here from this point to this middle point, h. Okay, so here let me take this At this point x equal to, let me take this distance is b here up to this point. This is b plus h, so this is b plus h, let me take, and here x equal to b, or this is x equal to b here at this point. This distance is b, x equal to b, or x equal to b on this plane, and at this plane x equal to b plus h. This is x axis, let me take O, this is a point here, this is y axis, y dash, x dash axis. Origin O, we have taken center of this curve, this sphere. Okay, so these are two planes, plane surface areas. Now we have to find out what is the area between these two curves. Okay, so this curve of the circle, sorry, this circle area, we will take x squared by y equal to a square, that will take the sphere, or the circle, equation of the circle. Now this semicircle is revolve again about this axis, but we have to find out the area between these two. The area between these two, only limits will be b to b plus h. b to b plus h if I take, so this distance between these two is h here. So b to b plus h, we will take the limits, then this area between these two planes will be calculated. Okay, so that is the point here, 2 pi ah. We have to prove where a is the radius of the sphere and h the distance between the two planes. Okay, again that x square plus y square is equal to a square with the equation of the circle here, be the, for this semicircle is revolved about this with the equation of the circle here. Okay, which semicircle here, the semicircle, the same point, semicircle is revolved about diameter of it, then this sphere is obtained. Because of that, this is now x square plus y square equal to a square. This is the equation of the semicircle or circle. Circle's equation is this. So semicircle is revolved about x axis, then sphere is obtained, which we have clarified in question number 2. No problem. Now come to the point. So therefore, here we have to find out to find area of the surface between the two planes. It says to find, so that the surface of the spherical zone contained between the two parallel planes is this. Okay, to find the area of the spherical zone, between two planes, at the distance between them is this, distance between them is h. Okay, a is the radius and h is the distance between the two planes at a distance of h, at a distance of h between them. Okay, therefore limits, undoubtedly this limit we have taken from this point to this. Let me take here, this is b point, this is b dash point. So OB is b, OB dash is b plus h, because h is distance between these two planes, between them. So therefore the area of the plane, area of the surface of plane, area of the surface of the spherical zone, between two planes is given by, here a is equal to, again 2 pi here, limits we will take x equal to b to x equal to b plus h. Try to understand, this is y into ds again. So we have to find out here, this is twice pi I have taken, this is b to b plus h limits. Now y as it is, ds we will write ds upon dx into dx simply. Now let me find out what is ds upon dx here. That is the point. So let's find out what is ds upon dx. Therefore, Here equation of a sphere or a circle here, x square plus y square equal to a square. The radius of the sphere will be then a, no doubt. Differentiating it with respect to x, we get this is twice x plus twice y d by dx equal to 0 because a is constant. Therefore, d by dx is equal to minus x upon y. This is to take second equation. But ds upon dx we know is square root 1 plus d by dx whole square. So here ds is to be written down. That is the form. Okay. Form. We have to calculate this. So we have calculated this minus x upon y. That means it will be x square upon y square. This is nothing but x square plus y square upon y square. That means a square upon y square from second, because x square plus y square equal to a square from first equation. From first, which is nothing but a upon y. This is value of ds upon dx. Therefore, the area, let me calculate now. Therefore, area A twice pi I to 0 to A here, I'm sorry, this is B to B plus H, B to B plus H. Here, y into ds upon ds, this is twice pi I have taken. Y into ds, this is y, ds upon dx is a upon y into a upon y into dx, y cancelled out. This is nothing but twice pi into a I have taken out. This is b to b plus h into dx. With the integration of dx, this is 1 into dx, that means this is twice pi into a. Integration of 1 is x here, limits now b to b plus h, which is nothing but twice pi into a. Within bracket will be first b plus h minus b. We cancel out, so it's h into. The same answer is obtained. What is this? Area therefore is twice pi into a into h. This is what we have to prove. Twice pi h. The area of the surface spherical zone contained between the parallel planes is 2 pi a into h. This h has come out from inside after substituting the limits. Okay, after substitution of the limits, upper limit minus lower limit, we have obtained h. So h into 2 pi a, that means 2 pi a h. This is proved. Hence it is proved. Area is